Problem 14. How many ways are there to split the integers 1 through 14 into 7 pairs, such that in each pair the greater number is at least 2 times the lesser number? So to do this, we have to always start, when you want to do counting in general, it's typically starting from the most restrictive case down to the simplest case. So when you want to think of this, let's think about special terms within this series that have more restriction than others. Particularly, let's consider 7. 7 must pair at 14, right? Because it has to be at least twice. So what about numbers greater than 7 and less than 7? 8, 9, 10, 11, 12, 13, 14. Well, notice that 8 times 2 is already 16. So that means that these numbers, 8, 9, 10, all the way to 14, or actually to 13 because 14 is taken, they must pair with different numbers other than amongst themselves. They must pair with the ones that are less than 7. Given this understanding, we can enumerate one by one. Let's consider 8, right? Let's first consider 8. 8, right? What is 8 divided by 2? Because it cannot be multiplied by 2, so it has to be 4. So that means that the largest possible number it can pair with is 4. So therefore, any number less than 4 would also work. 3, 2, 1, right? We consider 8. Now let's consider 9. The thing about 9 is that what is 9 divided by 2? Well, you can't really do it, but 9 has to be at least 1 to 4 as well, because it cannot be 5, because 5 times 2 is 10. So now 8 and 9, essentially, they share the same set, which is 1 to 4. And let us keep that in the back of our minds for now. Let's continue to enumerate. Let's consider now 8 and 9, 10 and 11. Well, 8 and 9, they share the same population group because, 5 times 2 is 10, so it has to be 8 and 9 within this range. Well, consider 10. 10 divided by 2 is 5. So it's 5, 4, 3, 2, 1. But then notice what happens with 11. 11 is odd. And so 11 has to also match the same pair because 5 times 2 is 10, 6 times 2 is 12. 6 is too great. So 11 and 10 also share the same group. Now let's consider 12 and 13. 12 and 13, well, what is 12? 12 divided by 2 is 6. So 6, 5, 4, 3, 2, 1 would work. But then, like the same logic from previously, 13 must also be with the same set. Now that we have enumerated every single one, what can we say? We can say that we can now start to count off the number of pairs, right? Because 8 will have 4 pairs to choose from, or as 4 choices, right? Let's consider 8. Obviously, I can choose one of these 4 numbers, so I have 4 possible solutions. But then again, what happens when I choose a number? After I choose a number within this same set, 9 will only have 3 cases to choose from, right? Because consider this, let's assume I chose 3. Well, 9 cannot choose 3 again, so it has to be 4, 2, or 1. And so, since they both share the same set of numbers that are possible, if 8 take one of them, then 9 will have one less. So that must be 3 total cases. Now let's consider number 10. Well, 10, right, has the exact same problem. 10 cannot pair with the 2 numbers that 8 and 9 has already chosen, because the set of 4, 3, 2, 1 is included within the 10 and 11 set. So let's suppose 8 and 9 chose 3 and 4. Well, 3 and 4 are off the table, so that means we only have 3 possible ways to choose for 10. And let's say he chose 2. Well then, obviously 11 will only have 2 choices to choose from. And you see where this goes, right? Because now we have 4 numbers chosen, but this set is included within this set. So that means I chose 4, 3, 2, 1. Well, for 12, I have 2 possibilities, and then for 13, well, I'm just left with 1 possibility. And notice something special. Notice that 13 and 12, we ultimately will have paired up all the numbers less than 7 in the process. And so basically, we have found the total number of enumerations for the number of pairs that are possible. Multiplying it out, because it's and. 8 must choose 1, and 9 must choose 1, and 10 must choose 1, etc. And so this would be your final answer. Multiply it together, and you get your answer. So 3 times 3 is 9, times 4, 36. 36 times 2 is 72, 144. So your final answer, 36 for, yep, 144. Yep, so 144, that would be answer choice E.